Good evening, welcome back. And this gas state, that is states of matter, so we have seen the Boyle's law, Charles law, Avogadro's law, Gaseous law. Now we'll see further universal ideal gas law, right? So once again, that V is proportional to 1 by P at T and N constant. That is Boyle's law. I am writing the shortcut B, Boyle's law. Then V is proportional to T at P and N constant, Charles. V is proportional to N at P and T constant. This is Avogadro. This fourth, the Gaseous is nothing but the Charles law's extension only. So if you see this 3, we can write as V is proportional to 1 by P, T directly proportional, and it is directly proportional to N. If PV, if I am writing, is proportional to NT, nothing but PV equal to nRT, where R is called the ideal gas equation or universal gas equation. Now we will see what is the units of R. Units of R equal to, so nothing but PV by NT. P is liter, V is atmosphere, and N is per mole, and T is Kelvin. So units are liter atmosphere per degree per mole. If you see in the liter atmosphere, if it is joules, liter atmosphere will be converted into joules per mole and Kelvin. So what is the value of this thing? One we will derive. That was the P is 1 atmosphere, V is 22.7 liters at the 273 degree Kelvin and all. When we are taking, we are finding out the R value, and 273.315 is the Kelvin value, and N is 1 mole. If we are dividing, this will be nothing but 0.083 liter atmosphere per mole per Kelvin. If it is in the value of this one, this will be 8.3 joule per Nk. So these are the universal gas constant, most important and the very common this thing and all. The extension of this ideal gas equation equal to, what is that? PV equal to nRT. If I am bringing PV by T equal to nR. N and R all constants. That means P1 V1 by T1 equal to nR equal to P2 V2 by T2. That means nR, if I am omitting, P1 V1 by T1 equal to P2 V2 by T2. This is the another way of expressing the ideal gas equation. Fine. There are so many problems and all. We will see at the end of or in between whenever the opportunity comes. Now what is the relation between, because wherever the V is there, so we can go to the density also. So density and molar masses gases equation is nothing but, here you see PV equal to again nRT. So P equal to P by RT if I am writing, N by V. N is moles. That can be written as mass by molar mass or molecular mass into 1 by V. This M by V is nothing but D. That means D by M equal to P by RT. So R M equal to dRT by P. This is one way expression. Molar mass equal to, that means molar mass also can be found out from the same equations. Only thing is we are converting one form to the another form. So this is another way. Then comes to the Graham law of diffusion. From there, here it will be extension of the Graham law of diffusion is nothing but rate of diffusion equal to 1 by root D. D is density, root D. So we want to correlate, so further we are extrapolating. So, and what is R? R is rate of diffusion, is nothing but volume of gas diffused by time of the diffusion. This we will use afterwards. So now if you see, if I am writing R1 equal to 1 by root D1, similarly R2 equal to 1 by root D2, means proportional, all the time proportional. R1 by R2, if I am taking R1 by R2 is nothing but 1 by D2 by D1 under root. So this is my another way of expression. Okay, this if I am expressing it to the molecular mass, because molecular mass is directly proportional, we have seen here. D and M are the directly proportional. RT and P at that constant pressure and temperature. If I am taking constant pressure and temperature, molecular mass and the D is directly proportional. So R1 by R2 equal to root D2 by D1, like this we can express, or we can express D2 by D1 M2 by M1, we can express in this way. This also, or this can be further expressed in vapor density also. So if you see the vapor density is half of the molecular mass. That means half of cancel on the top and bottom. So it can be written as Vd2 by Vd1, where Vd is nothing but, here not the volume and this thing, V is nothing but, it is a vapor density. It is half of the molecular mass. So rate of diffusion is directly proportional to density, which is directly proportional to the molecular mass, which is directly proportional to vapor density of a gas. So further if we continue, then we can see the other extensions of this law. Then we will can go to the Dalton's law of partial pressure. Okay, thank you.